Okay, let's unpack this. Most of you listening probably have a handle on what a software bill of materials is, right? That ingredient list for software. But today we're going deeper. We want to really get into why SBOMs are such a game changer, specifically for these critical embedded systems. I mean, think about it. The software inside hospital equipment or the control systems for the power grid, if you don't know what's in there, finding a vulnerability. It's like searching for a needle in a haystack, a massive one. So our mission today is to figure out, okay, what is an SBOM really? Why is it becoming so foundational for embedded security? And what's next for this tool?
Yeah, and what's really fascinating, I think, is how something that sounds pretty mundane, an inventory list, how that actually becomes a cornerstone for, well, national security, public safety even. We see these high-profile supply chain attacks. The real power isn't just knowing what components you have, it's being able to instantly figure out the impact, the risk, across maybe thousands of devices the second a new flaw is found. SBOMs really give us that power.
Okay, so let's lay some groundwork then. For someone who gets the basics, how would you describe an SBOM to really capture its full significance?
Right. So at its heart, it's really a formal structured list, an inventory of, well, everything that makes up a piece of software, all the components, libraries, modules, everything. Think of it like that super detailed recipe card. It lists every single ingredient. And for each ingredient, you get crucial details, where it came from, what version it is, and really importantly, any known security vulnerabilities tied to it. That level of detail, that transparency, is just pivotal for accountability for actually assessing risk in software development.
That recipe analogy really works, doesn't it? It just clicks. Because if you don't know the ingredients, you're flying blind.
Okay, so let's zero in on embedded systems now. Why do SBOMs matter so much here? We all use these things constantly, often without thinking. Cars, smart thermostats, medical devices. But what makes them different from, say, the software on my laptop? Well, embedded systems are specialized. They're computers, yes, but they're designed for very specific jobs inside bigger systems, like mechanical or electrical ones. Unlike your laptop, which can do lots of things, these are built for one, maybe a few dedicated functions, often in real time. They need to be super reliable, super stable, and they are everywhere. Medical tech, industrial controls, cars, planes, consumer gadgets, you name it. Stepping back a bit, you can see why they're such targets. Think about healthcare, energy, transport. A failure or a compromise there, it could be catastrophic.
And the thing is, they're often built using lots of existing code, right? Third-party stuff, open source libraries.
Which is efficient, but it means vulnerabilities can be hidden deep inside, brought in by components you didn't even write yourself.
That's where the SBOM cuts through the fog, yeah.
Yeah.
Gives you that visibility, helps you spot the risks before they become real problems.
Precisely. It lets you get ahead of the curve.
So, given how critical that visibility is, what exactly are we looking for in an SBOM or for, say, a complex medical device? What are the key details?
Okay, yeah, let's get into the weeds a bit. A good, accurate SBOM for an embedded system needs several key pieces of info. First, obviously, the component name, like libsSL.1.1. Tells you exactly what my read is. Then, super important, the version information. Is it version 1.11g? Knowing the version instantly tells you if it's old, maybe vulnerable. You also need the supplier information. Who made this? Maybe the OpenSSL Software Foundation. Good to know the source. Licensing information is crucial too. Is it Apache License 2.0? You need that for legal compliance, avoid IP headaches later. Then there's the component hash, usually something like SHA-256. It's like a digital fingerprint. Verifies the file hasn't been messed with.
Okay, so name, version, supplier, license, hash. What else?
Dependency relationships. This is key. How do components link together? Does libsSL.so.1.1 need libcrypto.so.1.1 to work? Mapping that out helps you see the whole chain. And finally, maybe the most critical bit for security teams, known vulnerabilities. Does this component have a CVE number, like CVE 2020-1971? That CVE links directly to public databases detailing known security flaws, so you know exactly what risks you're inheriting. That full picture is what you need.
Right, that makes sense. So we know what should be in the recipe. How do you actually create one, especially for these embedded systems? What tools do people use?
Yeah, there are quite a few tools out there now for just looking at container images or file systems. SIFT is popular. Then you have the open standards, CycloneDX and SPDX. They have tool chains around them for creating and checking SBOMs, which helps make sure different tools can talk to each other. Commercially, you've got players like Black Duck, Fossa. They're pretty well established in the vulnerability management space. But some newer tools are pushing things. Endor Labs, for instance. They try to go beyond just looking at declared dependencies. They dig into those transitive dependencies.
Ah, the dependencies of dependencies, right? The hidden stuff.
Exactly. The things your direct dependencies rely on, which can be a huge blind spot, and their focus is there. And then for systems using a lot of C or C++R, which is common in embedded, Run-Safe Security has an interesting approach. They generate the SBOM as part of the build process itself.
Okay, so there are tools, but just having a tool isn't enough, is it? What are the best practices? How do you make sure these SBOMs are actually, useful?
Good question. It's really about making it part of your process, not just a one-off thing. First, automation is key. Integrate these SBOM tools right into your CI/CD pipelines, your automated build and deployment process. That keeps them up to date. Second, be thorough. List everything, all components, even those tricky transitive ones, plus versions, licenses, suppliers. Don't cut corners. Third, keep them fresh. Update the SBOM whenever you update the software, new components, patches, whatever. It has to reflect reality. Fourth, use those cryptographic hashes we mentioned. They're vital for integrity checks. Fifth, definitely include the known vulnerabilities, the CDEs. That allows for immediate risk assessment. And yeah, ensure license compliance for everything. Maintain clear documentation. Be transparent. It's about discipline.
Okay, got it. So we know what they are, how to make them best practices. Let's get to the payoff. How do SBOMs actually make embedded systems more secure?
Right, this is the core benefit. It's fundamentally a proactive security strategy. Because you have that detailed inventory, your security teams can immediately map known vulnerabilities, those CVEs, to every single component in your system. Think about it. A critical flaw is announced in some common library. Without an SBOM, how long does it take you to even figure out if you use that library, let alone which version and where? Days, weeks.
Yeah, it could be ages. You're scrambling.
Exactly. With an SBOM, boom, you query it. You know instantly which devices, which software versions are affected. That speed is crucial for response.
So it's not just knowing there's a fire, it's having the floor plan instantly to find it and put it out.
Precisely. And by keeping those SBOMs updated and constantly checking them against vulnerability databases, often automatically you can catch issues fast. Automated tools can flag new CVEs relevant to your components, letting teams patch or mitigate way quicker. It cuts down that critical exposure time.
And I guess it helps prioritize too, like you see a vulnerability in a really core component versus something less critical.
Absolutely. Analyzing the SBOM lets you focus your efforts. You tackle the biggest risks first, the vulnerabilities with the potentially highest impact on your specific systems. It guides your security strategy.
Okay, it sounds incredibly valuable, but it can't be that easy, right? What are the real hurdles? What challenges do organizations actually face trying to do this, especially in embedded?
Oh, definitely not always easy. There are real challenges. One big one is just the sheer number of third-party and open-source parts in modern software. Managing that complexity is tough. Then you have the constraints of the embedded devices themselves, limited CPU, limited memory. Generating and storing a super detailed SBOM right on the device might not be feasible. Keeping track of component versions accurately, especially across lots of different products environments, maybe over long life cycles, that's a headache. Consistency is hard. And yeah, the standards thing is still a bit of a challenge. While we have formats like SPDX and CycloneDX, getting everyone in the supply chain to use them consistently, that causes compatibility friction.
Trying to bake a cake with recipes using different units. Grams, ounces, cups.
Exactly. That's a great analogy. Makes it hard to get a clear, unified view across everything.
Okay, so those are the problems. What about solutions? What can companies actually do to overcome these hurdles?
Well, a lot of it comes down to tooling, process, and frankly, education. First, lean on those automated tools we talked about, SPDX, CycloneDX generators, commercial options. Let the tools do the heavy lifting. Second, build SBOM generation right into your development workflow, your CI/CD pipeline. Make it automatic, make it routine. It shouldn't be an afterthought. Third, really commit to adopting standardized formats. That's crucial for interoperability both internally and with your suppliers and customers. Fourth, conduct regular audits. Check your SBOMs. Are they accurate? Are they complete? You need that verification loop. And finally, train your teams. Developers need to understand why this matters and how to do it right. Good practices in dependency management, keeping things updated, that helps immensely.
Makes sense. It's a combination of tech, process, and people. So, looking ahead now, let's pull out the crystal ball. What's the future look like for SBOMs in this embedded world? Seems like things are moving fast.
They really are. Government directives are a big driver, especially in the U.S. Things aligning with NIST guidance on secure software development are pushing SBOM adoption hard. Beyond regulation, if we zoom out, I think automation and AI are going to play a much bigger role. Streamlining the creation, sure, but also helping analyze them, identify vulnerabilities faster, maybe even predict risks.
Interesting. So like SBOMs getting smarter, maybe integrating real-time data.
Yeah, potentially. You could see future SBOMs maybe linking to real-time monitoring data, using machine learning to spot anomalies, using big data analytics to get deeper insights into software integrity over time. And the push for standardization will continue. As more regulations recognize specific formats, that will drive wider adoption and better interoperability. Ultimately, we'll see SBOMs become even more deeply embedded, pardon the pun, into DevSecOps practices, catching issues earlier and earlier in the life cycle.
Okay, so let's quickly recap this deep dive then. Software bills of materials, or SBOMs, they're really becoming non-negotiable for securing embedded systems. They offer that critical transparency, help track vulnerabilities rapidly, and just fundamentally improve risk assessment. Getting this right is vital for security in, well, pretty much every critical industry.
And that really brings up a final question for you, the listener, to think about. We live in a world that depends more and more on these embedded systems every single day. So how will widespread SBOM adoption really change how we approach security for, well, everything around us, our homes, our cities, our infrastructure?
Yeah, think about that software recipe next time you use your car or go to the hospital or just flip a light switch. Imagine a world where every critical piece of tech had a clear, verifiable SBOM. How much safer could we be? Definitely something to chew on. Thanks for joining us on this deep dive.